Hi, I'm Steven Feuerstein, and I write practically perfect PLSQL.
Greetings and welcome to the PLSQL channel, a series of video trainings on the Oracle PLSQL language. My name is Steven Feuerstein, and I'm a PL/SQL developer just like you. This lesson is part of my series on bulk processing in Oracle PLSQL. It's actually the final lesson in the series, in which I focus on converting to bulk collect. So the idea here is, how do we take code that exists in our old-fashioned format that doesn't use these great features and upgrades them to the performance levels of a bulk collect and FORALL process. So converting to bulk processing, the agenda. So we're going to take a look at the process by which you go from what I would consider to be old-fashioned code to the new approach using bulk processing features. And basically what it amounts to is going from an integrated row-by-row approach to phased processing. And we'll also take a look at what it takes to communicate from one FORALL statement to another and why that's necessary. So first of all, let's start by talking about what I call the old-fashioned approach. Here's a piece of code that accepts a department ID and a new salary, gets all the employees for the department ID, iterates through them using SQL operations, using the cursor for loop, and then within that loop has multiple DML statements. In fact, let's take a look at the code itself. So again, department ID in, new salary in. Find all the employees in that department. For every employee in the department, we've got a loop body that has within it a begin end. So the idea here is that I have multiple DML operations. First, I'm going to store the current value of the salary in the employee history table. Then I need to possibly make some adjustments to that salary. So I've got my program adjust compensation that might change the salary that they're going to get. Maybe they're not eligible to get the new salary. Maybe they get even more or less. And then I'm going to update the employees table with the new salary. So two DML statements for each row of information that I've fetched from the employees table. In addition, I have an exception section. I trap any error that occurs for either of these two DML statements or the adjust compensation program. I trap any error, I log that error, and then I continue processing. So what this begin end is saying is, even if an error occurs, don't stop. Keep going through all the rows of data, get as much done as you can. And this is one of the nice features of being able to put a begin end around any block of code. I can narrow the propagation of the exception and say, keep on going. So it's a simple program, 34 lines long. And there wouldn't be really any reason to change this unless you're working with, well, production volumes of data. So suppose I had 10,000 employees per department on average. This code will work quite slowly because we're doing these individual row-by-row actions. Now, as I hope you remember from your studying up on bulk collect, Oracle in 10G and higher will automatically optimize a cursor for loop to run at bulk collect levels of performance. So it's not necessary to convert the cursor for loop to improve performance. However, Oracle does not currently, and probably will not ever, automatically optimize DML statements into FORALL statements because there are too many possibilities of side effects affecting the logical outcome of the program. So if we want to get the best performance out of this program, we have to convert the insert into a FORALL, we have to convert the update into a FORALL, and they have to be two separate FORALLs because FORALL statements can only have one DML statement inside of them. FORALL statements require a collection to drive the processing. Let's just pull up an example of that just to remind you all. So if I have a FORALL statement, here we go. There's my insert statement. I need collections that reference the iterator for an individual element within the collection to drive the FORALL statement. You can't use FORALL without collections. So if we convert the insert into a FORALL and the update into a FORALL, we have to drive it with a collection. Where's the collection going to come from? It's going to come from a bulk collect. So even though we do not need to optimize the for loop into a bulk collect in and of itself, we will, when we have DML statements inside the for loop, need to convert the cursor for loop as well into the bulk processing feature using bulk collect in order to get the full leveraging of these features. So when I look at a piece of code like this, In fact, in general, the advice is whenever you see a piece of code like this, whenever you see a cursive for loop or any other kind of loop that has within it one or more DML statements, these are prime high priority candidates for a conversion, for an upgrade to the bulk processing feature. So let's take a look at how we do that. Again, notice we've got 34 lines of code, relatively straightforward, easy to understand. Now what I'm going to do is show you the alternative or the implementation in the cursor for loop to bulk 5 file. And just a first thing to note, 137 lines of code. So the volume in general, when you do these conversions from non-bulk to bulk approach, your code is going to get larger and more complex. And of course, that's usually something you don't want to have to deal with, or you don't want to have in your code. But in this case, it's pretty much the required outcome of this kind of conversion. Your code will get larger. It will get more complicated. You have to be very careful about how to write it. But you get an incredible boost in performance, perhaps 10 times improvement in performance. So let's go back to PowerPoint, take a look at in the broader perspective, an overview of what kind of processing, what kind of change you have to go through in your code. Then we'll come back and talk about what I've done here. So what it comes down to is that you're going to use a phased approach with bulk processing. Now, when you've got this cursor for loop and the row by row processing, it's very nice, it's integrated. Everything happens for a single row in that single iteration of the loop. We can put in all the specific logic. Again, we can trap the exception and then keep on going. It's very elegant, simple code. Unfortunately, it's too slow. And when you move to bulk processing, you end up working in a phased approach. So we've got data in one or more relational tables. And phase one is we get the data out from the tables as quickly as possible using bulk collect. Whether we do an unlimited bulk collect or use the limit clause, which would be the preferred option for production code, we fill up the collection with data, or maybe multiple collections. Phase two is modify the contents of the collection according to your requirements. Maybe I need to change the salary, remove some rows, make all sorts of modifications, but do that within the collection itself using PL/SQL code. And then phase three, use FORALL to push the data back into the relational table. So you can see there's a kind of a round trip here, from the tables to the collections, from the collections to the tables. And the reason I like to break it out into these three distinct phases is that I think that we should consider the FORALL a mechanism for pushing data to the tables, not an opportunity to do lots of interesting and different kind of computations. Do your computations, do your changes to the collections in your PL/SQL code. And by the time you're doing the FORALL statement, you're doing nothing but taking the contents of the collections, pushing them back across. So that's the general idea. Let's go back to our code and do the translation into phases and walk through the code step by step. But here, first of all, is the basic idea. At the bottom of my 137 lines of code, we'll find a relatively small begin end block, the executable section of my code. It's just about 10 lines long. And you can see that I've expressed the different phases in subprograms in my code to help me organize it and understand my code more effectively. So first of all, I've declared a cursor. Inside my cursor, I'm going to set up a loop because I want to use the limit clause. But I've hidden away the actual fetch into its own separate program. So fetch next set of rows, that's phase one. Get the data. So get my next 100 or 1,000 rows of data. Step two, phase two. Phase three, how interesting. Now, I talked about phase one, phase two, phase three, but let's go back a moment. What if phase two is not necessary? What if I don't need to modify the contents of the collection? What if I need to take the contents of that collection from one table and simply deposit it into another table, which is what I'm doing with my insert statement, insert into my history table. So here's an example where I've set out your three phases, but of course in the real world, things change. So phase one, get the data. Then I'm going to immediately do a quote-unquote phase three and insert data back into the history table. Then I'm going to do my phase two, which is adjust the compensation for the arrays, adjust the salary values in my array structure. And then phase three, the final step, push the data back to the database. So I simply wanted to point out here that we can talk about in general the way to think about it, phase one, phase two, phase three, but don't too rigidly apply those phases. You might have different sequences of events that have to occur. So that's the basic idea in terms of the major steps. Let's take a look at the code. Now, CFL to bulk 0 is the starting point of my conversion process. CFL to bulk 5 is the ending of this particular set of steps. So off to the code we go. Again, here's my original code, 34 lines. Declare the cursor. Inside my loop, do the insert, adjust, do the update. In my new approach, again, at the bottom of my 137 lines of code, I have a very small amount of code. It's my execution section. And what I've done to make my code more understandable is use subprograms, local subprograms. So within my main procedure, here's my update for department. I have sub-procedures below that. So these are called local or subprograms, and they're a great way to organize your code to make it more understandable. So this body of code now, the main execution section, is very short, very easy to read. In fact, I can literally read it. Open the cursor. Fetch the next set of rows. So I'm going to pass in my bulk limit. I'll show you the parameter in just a moment. I'm not hard coding the limit clause. I get back employee IDs, salaries, and hire dates. I exit when there are no employees left. Then I insert my history rows. Next, I adjust the compensation for the arrays. So for all these employees, what happens to the salaries list? And then I update the employees. So this is simply a high-level description of what I'm about to do, hiding the details, making it easy at a glance to say, aha, I understand the flow of this program. Now let's get into the details. Okay, so up to the top, my program takes a department in and a new salary as the original one did. But I've also added a third parameter, the bulk limit. I don't want to hard code the limit clause. So I pass in a default value of 100. Great. Now whenever I run this program, I can change the limit. And maybe I want to pass in 1,000 or 10,000 if I'm working with a very large volume of data. I'm doing this as a batch process on Saturday morning, so there's no possible problem in terms of memory consumption and conflict with other users. So that gives me additional flexibility. Next, notice I've declared an exception. So the FORALL statement, when using the save exceptions clause to trap and hold exceptions for later, if it encounters any exceptions, will raise the -24381 error. I never want to hard code that in my exception section, so I declare an exception called bulk errors, and I associate that exception with this number. Okay, next, and the big reason for the bulk of my code is that I have declared a separate collection for each one of my values that I'm fetching out of my table: employees, salaries, and hire dates. And there's my cursor. Now, as hopefully you remember from studying up on FORALL, even though I can bulk collect into a collection of records, I cannot reference the fields of those collections of records inside a FORALL statement until Oracle 11G. So I'm going to declare 3 separate collections. It's a lot of volume of code. Again, in Oracle 11, you can shrink this back down to 1 collection of records, but for the code that you're writing in Oracle 10, not possible. So I declare my 3 different collections. I declare my cursor. And again, here's the kind of code I could use, the little typo in it. Here's the kind of code I can use in Oracle 11, just 1 collection of records. Okay, so next step, or the first step, is fetch next set of rows. So fetch next set of rows, it takes in the limit, returns my 3 different collections. And it's nothing more than a fetch bulk collect into, specifying my 3 different collections, unfortunately, instead of my collection of records, and then limit bulk collect in, bulk limit in. So again, I avoid the hard coding of my limit. So that gets me my next, by default, 100 rows of data. Excellent. So I'm ready to go. And of course, I stop when there's nothing in my collection. Next, insert history. Insert history. So I've got a whole bunch of rows in my employees, my 3 different collections, up to 100 by default, and I want to push them into the database as part of my audit process. So FORALL, go from 1 to the count of employees. I know that my collection is densely filled because it was populated with the bulk collect. Either it's empty, in which case I go from 1 to 0 and do nothing, or there are 25 or 75 or 100 rows of data, and I can access every element between 1 and the count. I include save exceptions. Why do I do that? Well, in my original example, if anything goes wrong with my insert, I want to stop the block of code. Of course, it will stop automatically. Log the error and continue. So I need the save exceptions to do that, to allow the continuation. Also notice, if my insert fails, my update statement never occurs. And that's one of the trickiest parts of this example and the conversion process. When I have multiple DML statements in the same block of code, I have to have multiple FORALL statements. And if I have to communicate some kind of relationship between the two of them, it can get tricky. Here, it's just a natural outcome of the block definition. If my insert works, I go and do my update. If the update fails, I log the error and continue. If my insert fails, I skip over the update entirely, never do it, and then I log the error. So I have to reproduce the same kind of behavior inside this code. So, save exceptions. Then I do my insert. Notice I indicate or reference every single collection. So multiple collections, the values correlated together. If anything goes wrong, I trap the exception. So maybe 3 out of 100 had an error. It's all saved up by the save exceptions clause. The pseudo collection SQL %bulk exceptions is populated inside my bulk errors handler. I simply go from 1 to the count in that pseudo collection. I log the error, and I can use the error index to identify the row in my arrays where the error occurred, and the error code tells me the Oracle error number that was raised. So I log the error. Next. Now here's the big challenge. Something went wrong with my insert, therefore my update statement should not execute. But notice my update statement is now an entirely different procedure, which we'll come to in just a moment. So I have to find a way to communicate from this FORALL to the next FORALL that an update should not occur for this employee ID. In fact, for this employee ID. So how should I do that? Well, there are any number of approaches you can take. The simplest in this case, since I'm going to be doing an update on the employees table, and the update has a where clause where employee ID equals the item in the employee ID's collection. Why don't I just get rid of the employee ID from the collection? If it's not there, you can't update it. So I'm going to communicate this failure to the update phase by deleting an element from the employee ID's list at the location where it failed. So there's an example of using the SQL %bulk exceptions pseudo collection value to drive the processing, or the future processing, the next phase processing, in my program. Now this is fairly application specific. You can't always just delete a row and have that be all the information needed to communicate to that next DML statement. The main thing is to be aware that when you start with multiple DMLs in the same loop and you switch to FORALL, you will often need to have some way of communicating the relationship between the two, whether it's simply that you shouldn't do this one if this one failed, or maybe something else. So you'll probably build up or modify the collections to do that. So for every row in which the insert failed, you get rid of that employee ID. Okay, that's pretty neat and elegant. But now we've got a challenge. It's time to do the update. I'm sorry, it's actually time to do the adjust compensation for arrays. So I did phase 1. Then I violated my sequence of phases. I did phase 3 because I had no need to adjust the arrays before I did the insert into the history. But before I do my update to employees, I do need to adjust my compensation, and I have a separate program, adjust compensation for arrays. And there's really nothing interesting here because it's all application specific, but you would go through all the elements in that collection, make your changes, and then go back out and do your next phase. And notice there's a little comment here from one of the courses I did several years ago. You can't go from 1 to count here because the employee ID's array might have lost some data. I might have done a delete. So what I need to do is start from the first, and while my index is not null, adjust the compensation for that one row, and then go to the next element in the array. So you always need to be careful about when you can make assumptions about an array being densely filled. And if it's not, if you can't guarantee that, make sure you always use this kind of loop to iterate through the contents of your collection. So that's my phase 2. Adjust the compensation, massage the collections, get them ready to push into the database. And then finally, my update employees. Now, because I may have removed one or more employee IDs, in fact, the collection might be entirely empty, I cannot, inside my FORALL for update, use go from 1 to the count of employee IDs. Now, prior to Oracle 10G, this would present quite a challenge because I have gaps in my collection, and the only format I can use for the FORALL statement would be go from high to low, 1 to count, first to last, where every element between the low and the high values has to be densely filled. But in Oracle 10G, Oracle has added the indices of and values of option. So what I can simply say now is, for all the index iterators, or use the index values as an iterator if it's an index in or of the employee IDs collection. So I simply add the indices of clause. I specify the same bind array as I use in my where clause. And now, if I deleted one or more of the elements in that collection, the indices of approach will simply skip over those undefined elements. So if I deleted row 3 and row 17, then when it will use rows 1 and 2, it will find employee ID 1, or in location 1, let's say 137. It will then update the employees table for employee ID 137 in index position 1, and it will use the salaries and the hire dates in index position 1. It will automatically correlate across those different collections. So the indices of really makes this communication process quite simple in this example, and in fact I think in many cases this will be the primary application for indices of and maybe even the values of clause. You have a way to communicate between multiple DML operations. If anything went wrong, of course, I included save exceptions. So I handle that bulk errors exception. I go through all my different exceptions. I log the error, and then I'm done. So we took a relatively simple, quite elegant and simple to understand piece of code that directly expresses the logic. Do the insert, adjust, do the update. If the insert fails, don't do the update. If anything goes wrong, log the error and keep on going. And I was able to successfully convert that into a bulk processing approach. The code is more complex. There are definitely a number of critical issues to address. Most importantly, the communication mechanism between your multiple DML statements, your multiple foralls, which I took care of by doing the delete from the employee IDs and then switching to indices of. So the bottom line is that it's certainly possible to do this conversion. In most cases in the real world, you will have multiple DML operations. There are a number of complications to address. Make sure you don't hard code that bulk limit. Make sure that you use these local subprograms to make your code easy to understand for somebody to come along later and say, aha, these are the different steps I performed, or you performed. Now I need to go and manage those steps, but it's easy for me to get my head around it. To draw some conclusions. Without a doubt, from a performance standpoint, the for all statement is the most important feature to be aware of. Bulk collect, of course, is very valuable as well, but Oracle will often automatically optimize your cursor for loops for you, so it's less of an issue on a day-to-day basis. But you should be looking for every opportunity to convert to bulk processing. You should look for every loop that contains DML statements inside of it and do the conversion to bulk processing. No question, there's a big trade-off. You have increased complexity of code, you have a more difficult code base to manage, but you get dramatically faster execution, perhaps 10 times faster or more. So don't convert those cursor for loops if they're read-only, if they don't have DML statements. But if you've got those DML statements inside them, go through these steps, be aware of the different phases, make sure that you figure out what you need to communicate between your different for all statements, and then decide how best to do it, and you will have some really excellent high performance code. Of course, also watch out for the impact on PGA memory. This is always an issue when working with collections. So one of the other big changes from going from the row by row approach to the phased approach is I've introduced these 3 different collections. And that means that every single process running this job, running this program, will allocate the memory to manage the collections that both are filled from the bulk collect and drive the for all processing. And you need to make sure that you've got sufficient PGA allocation for the number of simultaneously connected users running the job. Something like this is most likely a batch job. PGA memory is less of a concern because you're not worried about the scaling up of 10 or 100 simultaneous connections. But it's always something to be aware of when working with collection-based features.